Hey guys, hello everyone. So, our next session explores enhancing UN R155 to address AI specific cybersecurity risks. With AI, including large language models, increasingly integrated into safety critical automotive systems, new threats such as adversarial attacks and data poisoning are emerging. So, this presentation discusses current gaps in regulations and proposes extending frameworks to include AI focused security measures, leveraging standards like OWASP, Top 10 for LLMs, MITRE ATLAS, and the Automotive Threat Matrix. It also highlights how cybersecurity management systems can evolve to ensure secure AI development throughout the vehicle lifecycle. Joining us on stage is Natasha Alkhatib, cybersecurity leader at Symbio, with a PhD in AI for automotive cybersecurity and extensive experience in AI ML based intrusion detection, threat modeling, and aligning cybersecurity strategies with ISO SA 21434 and UN regulations. Now, please welcome Natasha Al Khatib to the stage.
Hello, everyone. Thank you, Krishna, for the introduction, and thank you for joining us in this today's session. So today, I would like to talk about how we can actually enhance the UN regulation number 155 to better address the cybersecurity risks that are actually related to the artificial intelligence technologies, whether we're talking about the traditional AI algorithms or the advanced one that are more specifically related to the generative AI algorithms. And so today, as you can realize, as AI is coming increasingly integrated into today's vehicles, it brings not only powerful opportunities, but it also adds a new and complex vulnerabilities. And so the point of my today's presentation is to actually shed some light on why these AI-related risks need some specific attention, I would say, and how we can discuss the practical steps so that we can strengthen the UNR 155 so that it can remain future ready for the covering of attacks on the AI algorithms. And so, as Krishna has mentioned, I'm a cybersecurity leader at Symbio, and prior to that, I have done consultancy at ETAS BOSCH. I hold a PhD and a master degree in AI for automotive cybersecurity from Institut Polytechnic de Paris. And so, in order to illustrate today's problem, let's picture this. It's Tuesday morning in 2025, and let's imagine Sarah is actually commuting to work in her level 4 autonomous vehicle. It's catching up on emails while her car is actually handling a high velocity on the highway traffic. And so suddenly her vehicle's AI perception system will encounter something that it has actually never seen before, a stop sign with some carefully crafted stickers that to human eyes look like typical wear and tear. But to the neural network that is actually integrated within the electronic controlling units within the vehicle that is processing the image, these aren't random stickers. These are adversarial perturbations, and that are designed by an attacker to make the AI system classify this critical stop sign as a speed limit. So we can imagine it as a speed limit for 45 kilometers per hour. So Sarah's car, unfortunately, will not stop. And second, a normal commute will turn into a disaster. And this isn't science fiction, colleagues. This is adversarial machine learning. And our current regulatory frameworks, the UNR 155 and other ones, aren't equipped to handle it. And so let's step back a bit and try to look at how we got actually here. The automotive industry, as we have all seen, it has undergone a fundamental transformation. We have moved actually from simple electronic controlling units to sophisticated ECUs that are handling AI algorithms and AI systems that are able to first perceive, second to predict, and third to decide. So that can take decisions and that our systems will rely on that for driving our vehicle. And so today's vehicles, as you are all saying, they are integrating AI across every critical function. So the first functionality that we are all aware of is the ADAS systems. So the ADAS system, they use computer vision for actually object detection. It's one of the main applications that we can imagine. The second one will be voice assistants. So we all know that they are powered by large language models. And the third one is the predictive maintenance that are actually based on machine learning algorithms. The numbers my colleagues tell the story. We have 74% of the executives that are being surveyed, and that by 2035 tell us that the vehicles will be actually AI powered. So here we're not just adding software to cars anymore. We're fundamentally changing how vehicles think, and here's the challenge. Everything we know about automotive cybersecurity was actually built for deterministic systems. And when I talk about deterministic systems, we are more into threats that cover buffer overflows, that cover man in the middle attacks, that cover malware, because these systems actually, let's say, they behaved predictably. However, traditional AI systems are different than the traditional threats that actually target the code vulnerabilities, the human errors, and the network. Why? Because AI systems, they are actually fundamentally different. They are statistical, they are probabilistic, and their behavior actually emerges from patterns in data rather than explicit programming. So the AI threat, as you can see in the slide, they are different. They target another type of attack services. They target the intelligence itself. And by intelligence, I actually mean the models, the training data, the decision-making algorithms that keep us safe on the road. And so this brings us to our regulatory framework. We all know the UN R155 that has been considered and still considered as our North Star for automotive cybersecurity since 2021. It has established the Cybersecurity Management System, and it has gave us the Annex 5, which is considered as our threat catalog. The Annex 5, as you all know, it brilliantly categorizes threats into a different kind of domains. We have the communication channels, we have the software updates, the backend systems, and more. It's fully comprehensive for the word that it was designed for. But if we look at the timeline, actually, the UN R155 was somehow finalized in 2021 when artificial intelligence was still, and especially for the automotive use cases, it was still experimental. It was still in the laboratories. In 2023, we have seen the explosion of some democratized, let's say, AI solutions, which is the GPT-3 that has just been released back then. And autonomous vehicles were actually still confined to test tracks and to and the adversarial machine learning was actually considered as, let's say, an academic curiosity. And now in 2025, we can see that the gap is clear, and our regulatory framework that are focused on automotive cybersecurity, they are 3 years behind the threat landscape. So here's our fundamental challenge. We're trying to actually secure AI systems with frameworks that are meant to be for traditional software. It's like we're trying to regulate aviation with maritime law. There's some overlap, but you're missing actually the unique risks of the flight. And so the current Annex 5 that we all know in the UN R155, it doesn't actually address the stochastic behavior that I have previously explained of the neural networks. It doesn't actually address the data-driven attack vectors like the poisoning and the evasion, because we all know we need data to do the training of these intelligent systems, and also we need the data to test them and to validate them. And the third critical point that it doesn't address is the model confidentiality. So by model here, I mean the models that are used to predict based on the artificial intelligence solution. And the third point that I would like to mention is the runtime model drift and the performance degradation. So this is actually not covered in the Annex 5, and which is very specific to artificial intelligence solution and not to traditional software-based solution. So, as we all know, the threats are real and they are happening right now. And today I would like to show you what we are currently facing. So let's start first with the adversarial input manipulation. You can see in the slide that I have listed here a paper that is called Dynamic Adversarial Attacks on Autonomous System that has been previously done by Shah and Al. The attacker have carefully crafted some physical perturbation, and this has led to catastrophic decision making by the AI solution. The problem is that this kind of attack is somehow reproducible and scalable. And if you want to know more about this attack, I highly recommend you to check their paper that is already available on publicly available on arXiv. Adversarial attacks are actually not the only concern. Data poisoning attacks, they target the foundation of AI systems. And by foundation here, I mean the training data. So we have to imagine actually an attacker who's gaining access to the data set that is actually used for training the perception system in the vehicle. By injecting some carefully crafted malicious samples, they can actually influence how the model will behave in some specific scenarios. So the researchers that have published the paper Byte and Switch, online training data poisoning of autonomous vehicles, they have proposed how poisoning training data can cause autonomous vehicles to misidentify objects, and which is very critical. The insidious part is that the model performs normally in all other scenarios, making detection extremely difficult. Then we have model inversion attacks that I have mentioned in the 2 slides earlier. So Yang and al., the researchers, they have actually made a comprehensive survey on how attackers can query AI models to be able to reverse engineer some sensitive information from their training data. And we all know some training data are considered as highly critical for these systems. So for automotive application, we can imagine that a private data could be extracting proprietary algorithms from competitors, for example, revealing personal data used in training datasets, or uncovering trade secrets about some model architecture. So the implication actually, they go beyond cybersecurity. It's about protecting the intellectual property and the customer privacy in the AI-driven industry. And the challenge is that current regulations don't account for this inevitable degradation of the AI system performance over time. So here's the encouraging news. We're not the first actually to recognize these gaps. Industry leaders, they are already working on numerous solutions. Let me start first by the MITRE ATLAS. They have actually developed a comprehensive taxonomy of adversarial tactics and techniques for AI systems. They include some attack pattern catalog, threat actor capabilities, and structured AI risk frameworks. The second initiative was made by the Auto ISAC through publishing their Automotive Threat Matrix that is actually now expanded for AI-centric attack vectors. And there you can check the adversarial attack mapping, the automotive ML threat intelligence, and the industry collaboration platform. And the third initiative that we're highly seeing for the moment is especially after the publishing of the GPT-3 model, is the OWASP Top 10 Large Language Model. So actually, OWASP has released their Top 10 for their large language model applications, where they address risks like prompt injection, insecure plugin interfaces, training data leakage, and many more. So the expertise exists, the frameworks are emerging, and what we need now is regulatory alignment. What happens if we don't act? The consequences actually extend far beyond just individual incidents. Every compromised AI system erodes public trust in autonomous vehicles. And every successful attack gives adversaries a blueprint for future exploits. Every regulatory gap will become a liability for manufacturers and a risk for consumers. We're actually at a critical juncture. The AI systems that we are currently developing today will be on the road for decades, if not more. If we don't secure them actually properly, we'll be dealing with the consequences for years to come. So the question would be, what is the solution? We propose actually extending the Annex files with 3 new sections specifically for addressing the AI threats. So I propose that the Part A would consider the AI vulnerabilities and the attack message. So this is a comprehensive catalog of AI-specific threats. The Part B should be considering the AI mitigation for in-vehicle systems, so we can consider implementing here or developing here some targeted countermeasure for vehicle-based artificial intelligence. And the third part should be considering the threat mitigations outside vehicles. We can imagine here the protection of cloud-connected components for some federated artificial intelligence solution. So This isn't actually about replacing the current frameworks. It's more about evolution. I see it in this sense. We're building actually on the solid foundation of the UN R155, while we are actually addressing somehow the unique challenges of the AI systems. So let me walk you through each part of that. The part A, as I mentioned, it will include the AI vulnerabilities and the attack methods. So you can see in the slides that I have just provided a sample for you, where I just focus on the three main type of high-level threats. The adversarial input manipulation, a famously known type of attack on AI systems. It should include evasion attacks and physical attacks as examples. The data poisoning that I have also explained, I showed you a research paper that talks about it in the autonomous vehicle applications. It should target the training data integrity and model behavior. And here, as we all know, the integrity is the fact that we manipulate and we change intentionally and maliciously the training data that's going to be used to train our models. The model inversion, here we are more focusing on the threatening and attacking the confidentiality of the solution that have the model confidentiality. So there will be the leakage of our model parameters, I would say, and also the training data privacy. And as I told you, this is not only limited to these high level threats. Each category that you see in this table, it should include a detailed sub-descriptions and specific examples that are relevant for automotive applications. We're not actually just listing the threats, we're providing also the context so that the automotive engineers know how to understand and address them. For the part B, we should map specific mitigations that for the threats that I have already covered in the part A. So here we're more focusing on the input validation and filtering to be able to counter the adversarial manipulation. We're focusing on the secure data pipelines to prevent poisoning attacks. We'd like to, for sure, use some solutions that have been already used in the traditional cybersecurity solutions like the encryption, so we can apply encryption on the models to protect against the inversion attempts and always protect the confidentiality of the information. And also we can focus on the continuous monitoring. This is also similar to how intrusion detection system works for traditional networks. So we can use somehow the same idea for detecting and responding to the model drift. So we can always check that the model is behaving in the same in the guidelines that we have already set. So these, as I told you, these aren't academic exercise. They are practical, implementable security measures that automotive engineers are able to deploy today. The third part is the part that actually addresses the growing complexity of AI systems far beyond individual vehicles. So here we're more talking about the API security, the over-the-air updates for verifying the machine learning models, the AI learning models updates. So as you know, as vehicles will become more and more connected, the AI systems are getting more distributed. We have already seen how federated learning works on one server that is going to update different end-based models. This will become a critical solution for the overall cybersecurity. But I just want to highlight that technical controls, they are just only one part of the solution. We also need to enhance the cybersecurity management system process to accommodate for AI-specific security risks. And this is actually the section number 7 that we already know in the UN R155 regulation. This actually means that the organizational management should involve AI and machine learning security experts in some cybersecurity teams. There should be risk identification for the artificial intelligence-based solutions. So we should know which kind of threat models to be used for the artificial intelligence-based solution. Am I able to use Stride, for example, or should I switch to another threat model that takes more into consideration some AI specific, I would say, patterns. The third point that I would like to highlight is the verification. So should I be considering the previous testing procedures, or we are going to work on a new AI specific validation and testing procedures for to make sure that the AI system is behaving as we expected and we want it to behave. So each of the 8 CSMS process, they need actually some AI aware enhancements, and by that I mean some AI specific processes. Our proposal actually doesn't exist in isolation. We are specifically designed to integrate, as I previously told you, with some existing industry frameworks. So here we know that MITRE ATLAS, where I have shown you, they provide the threat taxonomy foundation for the vulnerability catalog. The Automotive Threat Matrix offers actually some automotive specific threat intelligence that can help us inform our risk assessments for the AI-based use cases in our autonomous vehicles. And the OWASP top 10 large language models, they can guide our approach to application level AI security. So this alignment hopefully ensures that our regulatory enhancements reflect the industry best practices and the real-world threat intelligence. I want to also highlight why this matters and what are the benefits of this approach that can actually extend beyond just security. So by this solution, we are enhancing the security. We are providing comprehensive protection against some AI specific threats and attack vectors. We are more into enabling the innovation by clearly setting guidelines that allow faster and safer AI deployment in the vehicles of today and of tomorrow. And we are gaining more and more consumer trust because the robust security frameworks build confidence in the autonomous vehicles. And not only we are creating a unified approach that reduces the compliance complexity for diverse manufacturers. So here we're not just fixing security gaps, we are actually enabling the future of mobility. And here's what I'm actually asking from each of you. This is my call to action for everyone that is actually interested in the proposal that I'm currently presenting to you. So if you're actually working with manufacturers, I would like you to start incorporating AI threat modeling into your CSMS process today, if you haven't done so before. If you are in research, it's very important to contribute to your findings to the industry threat intelligence sharing. If you are in regulation, it's very important to advocate for the formal adoption of these Annex 5 enhancements. And if you are in consulting, I hope you help your clients to prepare for the AI security requirements that are actually coming and that have already came into different markets in the world. The expertise, I think, in this room is wide. It is actually representative of a collective knowledge that is needed to secure the AI-driven future in the autonomous vehicle industry. And so, as I told you before, we stand at a critical inflection point in the automotive history. The AI is actually transforms how vehicle perceive, how vehicle think, how vehicle act, and our regulatory framework must evolve actually to match this transformation. So the proposal that I have outlined today isn't just about updating the regulation. It's all about ensuring that the intelligent vehicles of tomorrow, they are as secure as they are capable. The UN R155 actually gave us the foundation, and now it's time to build the AI-aware security framework that will actually protect us and protect the vehicles of the future. So the question, I think, it's not whether the AI will transform the automotive industry, because I believe that it already had, and it's doing it now and in the future years to come. The question is whether we'll secure that transformation properly. From my own perspective, I believe we will. The expertise, as I told you, is already here. The frameworks are ready. The industry is actually aligned. And I believe that we should, and I would like to make this happen with the one that are interested in this proposal. So thank you for listening to me, and I'd love to hear your thoughts and your insights about this subject. Thank you.
Wow, that's a great presentation and insight on how we integrate the regulations and change. Now we have a couple of questions.
Thank you, Krishna. Yes.
So the first question, I'll show it on the stage, and here we have, there are four threats today that are not addressed in Annex 5, but by the time the UN makes an update, there will be more threats not thought of. What do you recommend to convince the UN to take an approach of a readiness framework rather than a list?
Yeah. I think, thank you for actually asking this very interesting question. Um, so this is actually the nature of cybersecurity. It's not it's a common problem in all sectors and technology sector, whether it's the network and the cybersecurity related to networks, cybersecurity related to traditional software, cybersecurity related to any kind of hackable systems and networks. It's not only something that is specific to artificial intelligence. The cybersecurity landscape is always evolving. Maybe in artificial intelligence, we are seeing it more evolving now because the AI has been developed and published without security by design. So this is the common, I would say, specific problem for AI. And we are now seeing it being used and deployed in all different use cases, especially in the autonomous domain. And we need to take into consideration some specific measures, especially that we already have some specific regulations like the UN R155, and which can actually imposes how we can solve this solution by proposing their Annex 5, the different threats in part A, the different solutions part B, and what can be also mitigated from external connections to the vehicle that we see in the part C. I would propose that we should actually take some action from this moment and at least try to include the threats that are realistic for the moment and keep the Annex 5 as dynamic as possible, not only for the AI solutions, but for any kind of solutions, given the fact that all threats can change. But there will always be data poisoning because this is how the AI function. There will always be some data to rely on, so we can hack the data. There will always be some models to predict and to solve certain use cases we are already fixing. So there's always possibility to hack the model through evasion. There is always this curiosity by the hackers to steal the data that has been used for the system. So there are for sure common threats that will not change over the time. Maybe the way that the attack will be done will change, but there will always be poisoning, there will always be evasion, there will always be model theft. And so we should somehow consider this from the start and be always checking how the attack will happen in order to achieve this goal, achieve this threat goal eventually.
Yes, yes, that's a great insight. Now we have another question.
Yes.
Nice. So we have EU AI Act. Article 15 states clearly that AI-based high-risk systems should implement cybersecurity measures to ensure robustness, that are adversarial attacks mentioned as example. Wouldn't this be sufficient to handle this challenge at EU level?
Yeah, I like also this question. The
Yes.
idea here is that, as you have already mentioned, Mr. Weinach, this is already in another act, and we should somehow state whenever it's possible in one regulation how to look for solution in another regulation. So we should actually do the updates whenever it's possible, especially that this is a new technology. The EUA Act is more recent than the UN R155 regulation. So this is why I think where it's possible to do the link and call for other regulation, we should do that. Already the UN R155 does calls for other standards, and they list some frameworks, like it lists the OWASP, for example, in its Annex 5. So yes, this could be actually a solution. Uh, the idea here is that since UNR 155 is focused on automotive cybersecurity, at least it's great to mention that for AI technologies, this is listed in other regulation. I believe that we should find somehow how to include this information, whether it's by extending the proposal or by including the proposal, and whenever it's possible to link to other regulation, we should be considering that.
Right, right, great, nice. So looks like your presentation is provoking more questions. That's good.
Yes.
So I have another question here. So as ISO SA 21434 supports UN R155 with a structured risk management framework, how do you recommend updating the standard to address AI-specific challenges such as model data poisoning or adversarial testing, which are not explicitly covered?
Yes, for sure, the ISO 21434 also should be updated because, as we know, in the ISO 21434, we already mentioned and recommend some threat modeling approaches that have been previously targeting traditional kind of systems. And as I previously mentioned, the AI is a specific kind of, you can imagine it as a software, as a program, an algorithm. It has a specific kind of threats that could not be um, uh, let's say sufficient enough to be described in the previously done or previously proposed threat models. I first recommend that there should be threat models specific to AI systems to study how sufficient the stride, the pasta, the dried threat models are enough for judging the or doing the assessment on the threats on the AI models. If they are enough, then why not include them? But based on what I know, or based on what I'm currently reading from research articles, and based on what I always know on how to hack the AI systems, I know that they are not enough. This for sure should be well studied. I'm just proposing a hypothesis, I would say, and at least it should be highlighted in the ISO 21434 to which limit these threat models could be used for this AI technology. And why this is very important, because as I mentioned, the AI is being increasingly integrated in diverse applications. In one of the slides, I have shown that it could be used for voice assistants, it could be used for the ADAS functionalities, it could be used even for cybersecurity. Now I can implement an intrusion detection system based on artificial intelligence in today's embedded devices like the ECU. So if the security solution by itself based on AI is not secure, so this could be a real critical problem, because I can hack it, I can spoof it, I can do some evasion and data poisoning on the data set that was used to train the intrusion detection system. So I I have answered a lot about discussion, because this is a very interesting one. But I would say that yes, the ISO 2144 should surely be updated to include verified threat model approaches for AI specific challenges.
Right. So yeah, this AI is getting into everything and making the life easy and at the same time making it tough too. So
Yes,
yes,
exactly.
attackers use this too. Yes. Thank you for the answer. And another point that someone Loan posted, that we should not forget that Annex 5 is only a baseline, nevertheless. Like, he fully agrees that other frameworks provide a strong baseline in performing the risk assessment.
Yes.
Yes.
I fully agree. This is just a baseline, but this baseline is well used. And in the we all know in the automotive industry, we highly rely on the Annex 5 to do lots
Mhm.
of risk assessments, to propose countermeasures. And since this is widely used and for different kind of systems, we should take care of it and update it so that it can be actually used also for systems that are nowadays and in the future will be deployed and that are very safety critical. So even though it's a baseline, I'm just focusing on the Annex 5 because of the value I have sensed in using it in across different sectors in the automotive industry.
Yes. Yeah. Um, okay. I don't see. So, do you think risk reward strategy plays an important role in NLMs rather than reinforcing the model with more data or adversaries?
Um, so I can maybe use other wordings for your question if I understood it well. So we're saying that if we uh, if we train well the model, if we protect it well, then there is no need for assessing its security. Is this the question?
So, w- I just put it here. So, there is a risk and a reward strategy that
Yes.
plays an important role in LLMs. Like rather than reinforcing with more data, which one plays better?
Very good question. I think that uh, I think that if we reinforce the model with more data and adversaries, that could be more helpful.
Hmm. Yes. Okay. Yeah, that was a great presentation. Any yeah, we definitely need to address this AI, and there was also another point like having an AI bomb is another
Definitely. This is a
point
very
that yeah.
interesting topic, and especially that we need to be able to, as I previously mentioned, we need to follow up the updates on the AI models. We need to update the AI models. We need to update them based on maybe features we'd like to, new features in the AI models that we'd like to include, or maybe because of a vulnerability that we have identified in the AI model. So this is just like how we have already done with traditional softwares and traditional systems. I use the traditional term frequently because, but I should clarify why I use it just for the sake of comparing AI-based solutions with non-AI-based solutions. So this is what I refer to by traditional. But yes, as you mentioned, we should for sure, if we look at the clause number 8 of the ISO 2144, this is something also that needs to be updated. We have already talked about updating the threat models listed in the ISO 2144, but for sure there are various sectors that should be well customized for the moment because we have these new solutions. We need to follow up the vulnerabilities of AI. We need to check if a weakness of AI solution is considered as a vulnerability. If that's the case, we need to update the threat models. We need to check if we have a bill of materials for the AI solutions and know how to patch the AI model whenever possible. There's a huge amount of work that is currently being that is going or it's already being introduced in the AI sector for the automotive use cases, and for sure the ISO 144, the YAN R155, and all the relevant best practices, guidelines, and regulation standards related to automotive cybersecurity should now be updated given the fact that AI is increasingly integrated into today's vehicles and today's mobility systems.
Yes. Yeah. The other challenge comes in from the supply chain, uh, where tier two, three use AI models to
Yes.
train their systems, and the up chain doesn't even know what data is being used to train. So there needs to be more regulations too. Yes.
Definitely, and this is where we tackle the tool management. So, how do we
Mm.
manage the tools that are used in the automotive industry and that rely on AI solution? Like, how do I manage a tool for threat analysis and that is based on AI? Or how do I manage another tool used, I don't know, for developing codes right now for the moment, and that is based on AI? So yes, we're tackling the clause 5, clause 6, clause 7, 8, 9, 10, until 15 for the ISO 2144. And good luck for us in all of this.
Yes. Okay. I don't see any questions. Okay. I That was a great presentation, and
Thank you.
thanks for taking time and presenting this and answering the questions.
Thank you, thank you. And if you have more questions, don't hesitate to reach out to me. And as I previously mentioned, best of luck for all of us in this.
Perfect.
Thank
Take
you.
care.
Bye bye.
Thank you. Bye bye.